Hello and welcome to the GCSE Physics tutorial for topic P5 forces. This tutorial will cover part 2 and look at gravity. So gravity is a force that occurs between objects. The bigger the object and the closer the distance between them, the larger the force of gravity. And it's the force of gravity that gives an object its weight. So the weight of an object is measured in newtons and it's calculated by taking the mass in kilograms and timesing it by the gravitational field strength. Now this gravitational field strength changes depending on where someone is in terms of Earth or in space or on a different planet. On Earth, the gravitational field strength is 9.8 newtons per kilogram or sometimes 10 newtons per kilogram. But in the exam, they will give you the gravitational field strength. So just use whatever they give you. But it's normally between those values. As you can see from these diagrams, but gravity is always a force that acts downwards. So what is mass and what is weight? Well, actually, people probably use the term mass incorrectly. Mass is not a force and it's measured in kilograms or grams. And the mass stays the same wherever you go. So if you were to go into space, you would have the same mass. It's the amount of matter you're made up of. Weight is a force, and that's measured in newtons, and that changes depending on the force of gravity. So if you were to go to the moon where there's less gravity, you would weigh less, but your mass would be the same. Weight is a force acting on an object due to gravity. When you're doing force diagrams, the size of the arrow represents the size of the force, and the way in which the arrow points represents the direction. So you can see here, this would show that the boat was moving forwards. Resultant forces, these are the overall forces on an object. If an object has a resultant force of 0, then it's either stationary, so not moving, or moving at a steady speed. When the resultant force is more than 0, then the object is moving, and that's because the forces are unbalanced. Here is an example of trying to calculate a resultant force. The forces up and down are the same, but if you look here, the thrust forward is 800 and the air resistance is 200. So overall, the resultant force would be forward by 600 newtons. You'll also need how to calculate resultant forces in diagrams. To do this, you will be given the forces acting on the objects. You would draw this out and use an appropriate scale. And then, to calculate the resultant force, you would draw a line from the tail of the first arrow to the tip of the last arrow, as shown here. And then using your scale, you will measure the length of this using a ruler. And that will give you the overall resultant force. Work done is in joules, and that is force times distance. If you pause the tutorial and try these questions now. The weight of a 3 kilogram object, well, you would times it by the gravitational field strength. In this example, I've used 10, but you might be asked to use 9.8. What is the work done? Well, remember, work done equals force times distance, so that would give 200 joules. What does a resultant force of 0 newtons tell you? Well, it tells you that either the object's not moving or it's moving at a steady speed, so the forces are balanced. In summary, we've looked at gravity.